do it is by using a spreadsheet because we're going to unfortunately have to do some math. So I'm going to start off with question number 1. Ignoring that I can't type. So it reads, and you could read this for yourself, most black bears, Ursus americanus, are black or brown. Occasionally a wet bear occurs, and this is due to a single mutation that replaces adenine A for guanine, which is a G. Those are parts of DNA. Bears with the A allele code for black or brown. Okay, I'm going to write that down. A equals black, brown, which deals with the dominant allele, which is going to be P, because we were told that. And GG genotype codes for the white. So G is white, which is going to deal with Q. Researchers have obtained these data. So they have for AA, there turn out to be 42 of them. For AG, there turn out to be 24. For GG, there turn out to be 21. So determine P and Q, then determine if we're in equilibrium or not. So to do this, so I just wrote down some data. I'm going to start building a whole bunch of stuff all at once, so it might look confusing, but it's because I'm typing it instead of writing it out. What I have are some traits. And here's what I have observed. If I have traits and observations, I can also have some expectations. I can have observed minus expected. I can observe minus expected squared. I can have observed minus expected squared divided by expected. I'm going to be fancy and square these. Format, cells, superscript. And now you all are thinking, ooh, that's the fanciest thing you've ever seen. Or not. I don't know. Sweet. So, first thing I need to do is figure out my P and my Q. My P's are my A alleles. So the question is, well, how many A's do I have? Well, if I look here for the AA, it says I have 42. So you're inclined to say, oh, that's 42. And the answer is no, it's not. I have 42 of the first A, where you see my mouse or the plus over it, but I also have 42 of the second A. So in reality, I have 84. I have 2 times the 42 because I have 42 of the first A, 42 of the second A. Because if I'm talking about alleles, P's and Q's, I have to look at every single option. For the AG, I have 24 of those. So I can add those up and I get 108. The grand total of these would be, add up these numbers, and then I need to multiply it by 2. So to do that, I put them in parentheses, times 2, and I get 174. So 108 out of 174, there would be my p-value. So if I want to figure out my q, I can do the exact same pattern, which is add 24. I'm also going to add up 2 times 21, which is 42. Add those numbers up, you get 66. I'm going to double check to make sure I did my math right. Yay. I'm going to copy and paste this over here. It says 0. That's because I need to tell it to look in the same spot. Dollar sign, dollar sign, dollar sign, dollar sign means don't change. Sweet. Copy, paste. Oh. Equals there divided by there. So now I have my P and now I have my Q. Good for me. So my P value is 0.621, my Q value is 0.379. The way I did that again is I just added up the number of A's, I added up the number of G's, then I divide by the total number of A's and G's, which turns out to be 174. So to figure out my observed, AA is like saying P squared, AG is like saying 2PQ, and GG is like saying Q squared. So my P squared would be 0.621 squared. 2PQ is like saying P times Q times 2, 0.74 or 471. The Q squared would be this number squared. If I add those up, if life is, well, yeah, it adds up to a 1. So the question then becomes, well, how do I get these numbers for expected? Well, I expect 39% to be AA, 47% to be AG, 14% to be GG. Well, my total is 87. So I should expect this percentage times 87 to be my expected value. I'm going to make it so it rounds. I'm going to have it round to 0. Drag it down. Hopefully it adds up to being somewhere close to 87. Rounding issues brings it to 88. Good enough for us. Now I just make it do the math. Observed minus expected. Observed minus expected squared. Observed minus expected squared divided by expected. Have a whole bunch of numbers. Drag it on down. Equals sum. Let's add up these numbers. And that there is my chi-squared value. So I want to make it look right. Chi is no. C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Wait, how did I miss it? Whatever. X squared. That's going to be good enough for me right now. So my chi-squared value is 13.85. My null hypothesis is there's no evolution occurring. My alternative is evolution is occurring. My degrees of freedom would be 3 choices, AA, AG, GG, minus 1, which is 2. So if I did this to, if I let P equals 0.01, my critical value turns out to equal, I look on the table, 921. If I pick it to equal 0.001, my critical value equals 13.8. So if I do this, I'm going to get 2 different answers. So at P equals 0.01, chi-squared exceeds the critical value, so we say we reject the null and accept the alternative. Oh yeah. There. Or I could say at P equals 0.001, the chi-squared value actually, is less than the critical value, so we fail to reject the null hypothesis. So if we want to be wrong 1 time out of 100, we would say, yep, this thing is not in equilibrium and evolution is occurring. If P squared is, I'm okay being wrong 1 times out of 1,000, I'd say, nope, evolution is still occurring because the chi-squared value, actually, sorry, it's still greater than, oops. We reject the null and accept the alternative, no matter what. Sweet. So that's one version. We could do the same thing for one of the other problems, like 7 or 15 or 16, but they all run along the same pattern. And the big deal is figuring out P and Q, you have to do it by hand, and that is by adding up each individual trait. So you have to add up for every single P and every single Q. So for the homozygous dominant, you have to take the number of observations and multiply it by 2. Homozygous recessive, take the number of observations, multiply it by 2. For the heterozygote, you add up that number into both the P and in the Q, which you saw here. Hopefully I didn't confuse you too much. Tiffany Ho is sitting in this room right now, and she's been staring at me saying, I remember this, and I don't miss it at all. So if you have questions,